Welcome folks, back for another session. So today what we want to do is we want to talk about multimeters. And basically what we're going to do is, first thing, when you open up your meter, brand new meter, got your manual, get rid of that. No. Gentlemen, ladies, they make the manual so that you can figure out what each and every part of your meter can do and what the aspect, what the limitations of the equipment are, and also what the ranges are. So it's important to note, and it says all over the front of your meter, not to exceed 600 volts, because that's the critical voltage level that the insulation, that's your probes, and the insulative effect of the meter can handle up to 600 volts, no more. So let's start together. We've got a couple of different sets of cables that come with it. So what we've got here, I've got a probe stuck. Alright, so these are what you're going to use for testing multimeter voltages, ohms, continuity. It also comes with these nifty little alligator clips which screw right on the tip of your probe. So if you're going to do multiple checks, you may want to use a neutral, or you may want to use one of the other legs to reference your voltage from, and that's what these are for. So it frees up one hand, and it's also a safety measure. The other object that comes with this is a thermalcouple. So this plugs into your meter as well. Now, I'll show you, we've got a switch here that enables us to plug this in. So let's start with the first thing on the agenda here. So I'm going to plug my test leads in. So now that I've got the polarity, so this is red, this is black, it's called common here, and it has a plus showing that it's plus voltage, so this is the high side voltage. Alright, so once we get the polarity correct, so now what we're going to do is we're going to talk about voltage. So here we have three phase, we have neutral right here, we have ground. So again, L1, L2, L3, neutral, and ground. Over here, we have our low voltage. So that's 24 volts AC. So what I'm going to do is I'm going to turn my meter on, and you'll see here in the upper left-hand corner that you either have a sine wave, which is a sideways S, or you have a straight line, which is DC voltage. So you can measure your car battery or your trailer hitch, make sure that that you've got the correct voltage for your brake lights and so on and so forth. So I can measure the battery in here, which is DC on that setting. So I'm going to switch back to the AC mode, and I'm going to put the meter up here so that you can see it. So now, the one important thing, no rings, no watches, no necklaces. The wedding ring goes in my pocket. So now what I'm going to do is I'm going to take a voltage reading across L1 and L2. And as you can see, I'm showing 209 volts. If I go between L1 and L3, I still have 209 volts, 209.3. This is neutral. With this reading, I'm getting 120 volts, and I should get the same if I go and reference ground. But in this case, because this is a commercial building, it's not at the same potential as what we talked about with the load center and breakers in your home. So the only way that you're certain that you're going to get 120 volts is to use neutral in one of the lines. So there we have 120, we have 120, and then when we go between phases, we have 208, 209. Over here, we're going to have somewhere in the neighborhood of 27.14. That's our low voltage side. So the next reading up here is for ohms. So if you want to measure the windings of a compressor, so remember they're additive. So when we go between common and run, that's going to give us one value. In this case, it's telling me that I have 4.3, 4.2 ohms. Actually, 4.1, 4.2. So now I'm going to switch over to the second terminal here. So now I'm reading 0.6, 0.7. So those two are going to add. So we had 4.2, 4.3, and we had 0.5, so additive, okay, now it's 0.6, 0.7. So 4.3 and 0.7 should be about 5 ohms. So now when I go between start and run, we should see them add up, and what I have now is exactly 4.9, 4.8 ohms. So it holds true. So the sum of these two terminals from common to start, common to run, are additive when you go across the start and run windings. Okay, the other thing we can do is we can check for continuity. That just tells you if the wiring is good between the terminals. Okay, simple check. We can do the same thing with a light bulb to see if the filament is connected to the base properly. We can also do the same thing with a heating coil. So now, let's back one up. This is ohms. So if we want to take a resistance value, so if I want to know what this heater actually has insofar as its resistance, I'm showing 11 ohms. So let me check the second part of the heating element, and we're showing 10.9, 11. So it's accurate. We have two separate sections of this heating coil. That's one way to see it. The other way is you can just use the continuity. So now we know that our heating coil is in good shape, and if we have a problem, it's somewhere else other than the actual coil itself. All right. So the next reading up the scale is microfarads. So I have a start capacitor, I have a run capacitor. So I'm going to measure the microfarad or the capacitance, and it's going to take a moment. As you can see, there's dotted lines across the bottom display. That's because the battery is charging the capacitor, and now it's showing me it's 156.6 microfarads. If I take the same set of circumstances and I want to measure the run capacitor, it's going to take a few moments to charge up. And now we have a value, 12.67 microfarads, which matches what the label on the front tells me. All right, moving right along. we also have a MicroAmp scale. So if I had a circuit hooked up and I wanted to take a current reading, I can simply connect it over the wire. All right, so what we're going to do now is we're going to take a temperature reading. So the thing that we have to do now is we have to switch the black switch in the down position, which enables us to be able to plug in our temperature probe. So now we can take our temperature probe. I've got a bottle of water here. So right now our water temperature is 75.2. The important thing to note is when you're using this probe, make sure that your fingers do not come in contact with it. So in other words, if I was trying to measure a temperature of a discharge pipe, I wouldn't want to put my big fat thumb on it, because now it's 83.5 versus 76, 75. So you can see that you can influence your own readings. So now you remove that, put the switch back in the up position, because in the down position it will not enable you to install your probes. That's a safety feature. So now we'll put the probes back in. Now one of the other functions that this meter has, if you set it on the voltage scale and you want to just see if you have voltage, so you can press the button here that says ACV, and now you can see that just being in proximity, I'm able to tell that I have live voltage present. So that's a plus for you guys out in the field. If you come up to a piece of equipment you've never worked on and you suspect that there may be a broken wire that's possibly grounded out, this is one way to test to make sure that the actual metallic case around the unit is not live. So simply to wrap up, this meter has a lot of functions. It really would be a great idea if you guys took the time to read through the manual before you begin the exercises. It does give you a complete list of what the ranges are that this thing is designed to measure. You can actually even measure frequency with it, so whether it's 50 or 60 cycle, or in the case of variable frequency drives, that may be an issue. So that may be something that you want to go and investigate further. So just to give you a reminder, so this was the common terminal on the compressor, this was the start terminal, and this was the run terminal. Between the start and the run is the summation of the other two windings. We also did a test that we tested the two separate elements in the heat strip. We tested the voltage, we tested the low voltage, we tested the temperature of the water, we tested the capacitor, we tested the light bulb. All right, folks, be joining you soon with another video. Thank you.